In this video, you will witness the struggles of an industrial automation designer trying to create a control system with IoT support. The employers were an engineering firm that built wastewater treatment plants. They wanted to shift from using PLCs to embedded systems, aiming to create their own electronic boards. This approach would reduce costs and ensure that maintenance and repair of their systems could only be handled by them, as they would have custom-designed systems that others couldn't easily obtain. This is the dream of every growing company. At first glance, the automation system they wanted didn't seem too complex. It involved a few digital inputs and outputs, some analog inputs and outputs, a high-speed counter reader, Modbus RTU, and Ethernet for communication between the boards. An HMI was needed for the user interface. So far, everything seemed normal. We could handle it. Oh, and they also wanted the ability to access, control, and monitor the systems remotely. It would be good if the systems could send SMS alerts in case of a problem. Alright. Of course, a web interface would be necessary. A server, user management, database, and security features would all be needed. But it was still an automation job. Could I handle it? I told myself I could and accepted the job. Let's start with the main control board. When it comes to communication, the first thing that comes to mind is the ESP32 microcontroller. In an industrial environment, Wi-Fi communication isn't reliable enough for me yet. So, let's explore Ethernet options. A quick Google search, and voila! The ESP32 Ethernet kit. This development kit includes an IP 101 GRI, a single-port 10/100ths fast Ethernet transceiver with an RMI interface. With an ESP32 Router E, all the components and connections are ready to go. It's a solid starting point. Combined with Platform I/O and Arduino libraries, we get support for JSON, MQTT, and SSL, all in one package. With its 240 MHz speed and dual-core processor, this embedded system can handle the job easily, especially with free RTOS support. What else do we need? We need to store a lot of data, like the total operating time of motors, delay intervals, alarms, and more. We'll need to update and read this data frequently. Flash memory isn't up to the task. It's too slow and has limited write-read cycles. After some more Googling, I found the solution: FRAM. With its SPI interface, it's fast and boasts a billion write-read cycles. The main board is basically complete, and our electronics partner will handle the rest. Now it's time to focus on the HMI solution. I know of an HMI option that can easily communicate with microcontrollers. Nextion. Its 10.1 capacitive touchscreen and UART interface will simplify our work. It features a Windows-based page editor and a scripting language similar to C. We'll have some design work to do. The next step is the I/O board. Since the I/O board needs to be capable of handling a large number of input and output operations, the ESP32 is not a good option. We need a microcontroller with many pins, generous with analog and digital inputs and outputs, and supports Ethernet. The Arduino Mega has plenty of inputs and outputs. How about using the ATmega 2560? Bad idea. Its 8-bit architecture, low speed, and RAM capacity could create a bottleneck for us. We need a microcontroller that can easily handle Ethernet communication while performing all input and output operations. This is where the STM32 series comes to our rescue. It has everything we need. An ARM Cortex-M4 processor running at 180 MHz, 144 pins, 2 MB of flash memory, 256 KB of RAM, our MII support, analog inputs and outputs. On top of that, its STM32 Cube IDE is free. Now we have the basic components we need for the embedded systems. In the next video, we will cover the solutions for IoT integration, server and backend solutions we selected, what we installed on the server, how we handled the communication, database, and a lot more. Please like and subscribe if you are interested in the next part.